Hi friends, today's video we will be discussing about the two different important topics. Basically, I would clarify your doubt about the differentiation between the nuclear reactions and the chemical reaction taking place in case of water. Okay, can you see here that which chemical process takes place? It is because of the transfer of electrons or the sharing of electron. I'm going to tell you in this video. Okay, and which how it is different from the nuclear reactions. I mean, here I have a salt. Could you see? This is the salt NaCl. So NaCl is being made because of which chemical reactions? What is involved here? And importantly, in this video, I'm gonna explain you about the formation of atom bomb as well, and in addition to that, hydrogen bomb also to be studied in this video. Completely I will clarify your doubt that how atom bomb to be made, how hydrogen bomb to be made, what are the discovery, who has discovered about it, and moreover we will be discussing about the two different process, that which process is taking place, because of which process the nuclear reaction takes place, or nuclear chemical reaction takes place. Okay, so let's get started. And today I will clarify your doubt about is atom bomb is really powerful or dangerous. In between hydrogen bomb and atom bomb, which bomb is really powerful and which bomb is really dangerous? How this kind of bomb to be prepared, by means of which phenomena, by means of which theory? Okay, so I'm here, teacher, gonna explain you about the most important topic of nuclear reactions, and of course I'm gonna give you a small brief of chemical reaction too. Okay, so you get started here. uh, I will be sharing my screen over here, so let us have a look of that. Basically, student, they try to understand that what are the phenomena involved in nuclear reactions and chemical reaction too. Okay, so in a very simplest way I love to tell you, try to understand it. Nuclear reactions, they're the involvement of nucleus. So very simple, nucleus is involved in nuclear reactions. Look at it. Nucleus, nuclear, the first two words itself is related to the nucleus. So that is why nucleus is being involved in nuclear reactions, not electrons. Specifically, you talk about the involvement. So there is the involvement of neutrons in nuclear reactions. Is it clear now? Now let me move on to the chemical reactions. So you asked me that what is involved here. So you can say that electrons are being involved in chemical reactions. In all sort of chemicals you could find in your day-to-day life, that is because of the electrons, not because of the neutrons. Remember it. Whatever the reactions you have, chemical reactions in our day-to-day life, that's going to be because of the electrons. Okay, it can be addition of electrons, or it can be the removal of electrons, it can be sharing of electrons, it can be transfer of electrons, lots more. So for example, let's say how chemical reaction is differ than nuclear reaction. In a quick, let me explain you. Let's say here we have salt. Can you see here? This is called NaCl, sodium chloride. On the other hand, in chemical name, so chemical name of salt is sodium chloride. So how sodium chloride is being made? The sodium chloride is made because of the sodium atoms and chlorine atoms. So here, let's suppose here we have a sodium atoms, and here we have chlorine atoms. When these two atoms being combined together, what happens? sodium chloride is being produced. Understand? So let's say how it is produced. How it is produced. So now let's say it is sodium chloride. So electronic structure of sodium is actually 281. Understand? So in the outer shell there are last 1 electrons in case of sodium. But in case of chlorine, the electronic configuration 287, because atomic number of chlorine is 17, right? So it has 7 electrons in the outer shell. That means insufficient of electrons we can find in case of chlorine, but there is excess of electron in case of sodium, because atomic number of sodium is 11. So electronic configuration will be 2, 8, 1. Clear? So now what happens, the excess electrons you can find in sodium. So sodium are of course metal, so it's going to transfer electrons. How many electrons? Outer shell there are 1 electron, so 1 electron is being transferred to the chlorine. So why this transfer takes place? Because of the stability. So sodium will become stable, and chlorine also on the other hand it will be stable. What stable? In the sense octet. Okay, chlorine will become octet rules, because in the outermost shell the electron number must be 8. So that rules is known as octet rules. Okay, it can directly transfer electron from sodium to chlorine to become stable. So now when a sodium is donating electron, so sodium will become Na plus. So remember, if at all a metal is giving electrons, how many electrons is giving? Accordingly, the sign of charge you have to put it. So 1 electrons is giving, so 1 Na plus 1 or 1 plus we can do it. Okay, and then chlorine received that 1 electron, so chlorine became 1 minus. Understand? This positive sign, negative sign will make them attract, and finally it's gonna form NaCl. Now this is called salt. Okay, this is because of the electron transfer. Similarly, H2O, water also can be made because of the sharing of electrons. In a different video we will discuss about what is the covalent bond, what is ionic bond, what are the combination reaction, oxidation reaction, reduction reaction, and lots more. Okay, this video specifically we're gonna explain about the nuclear reaction. So that is why if I explain in details about the type of chemical reaction, then the video is going to be a very large. Okay, so today the main topic to be explained is about nuclear reactions. Okay, so let me move on to the nuclear reactions here now. It's very simple, students. Just look at here. Here I display my slide. Okay, nuclear fission is a reaction in which the nucleus of atoms split into 2 or more smaller nuclei. You didn't understand, right? Let me have an example here. I have 2 mobile, for example, here. Okay. Now, this is now became big one. Let's say it is a big nucleus. It is a big nucleus. Okay. Now let's suppose we have neutron over here. It is SC remote. Okay, just let us assume it is a neutrons. When 1 neutron is being heated to the big nucleus, how it will be heated to the big nucleus. So as soon as you heat it, so this big nucleus will divide into 2 parts. Now how it is dividing, look at it. Understand? It was big. It was the larger mass of nucleus. It was heavier. So when you hit a neutrons, 1 neutron is required, not more than that. So it will be split into 2 types. So it became smaller size, it's smaller. So this is small atoms is called smaller nuclei. Understand? Nucleus divided into 2. So this is the phenomena of nuclear fissions. So here we have taken an example of uranium to show the nuclear fission reactions. Then you might have question, you might be asking question, teacher, so only why always the uranium? Why can't we take some other element too? So I would say that yes, of course, you can take any other element as well, but remember it. You have to take only unstable element, or what we call unstable isotopes or radioactive isotopes. We can say, on the other hand, we can't say radioactive elements. Then how do you recognize, is it radioactive element or non-radioactive element? How you gonna understand it? How will you understand? So you can understand because of how you will understand, is it radioactive element or not. So here I'm gonna share you the screen. Look at it. You have to know, is it radioactive or not, or which nucleus has high extra neutrons, which does not have extra. Okay, so it depends on that. For example, how do you recognize it? Which atoms has heavier nucleus, which has extra neutrons? Clear? So to understand stable nucleus and unstable nucleus, one thing you have to do is, it's very simple. Look at it here. If proton number is equal to the neutron number, or the number of neutrons will be lesser than the proton number, then that type of nucleus is called stable nucleus. Okay, so for example, one atoms, let us take here. Okay, which atoms? The carbon, carbon 12. So your carbon atomic number 6, its mass number will be 12. So you know that carbon has how many electrons? How many protons? How many neutrons? Can you tell me how many neutrons present in carbon atoms? So inside the atom, subatomic particles are the electron, proton, neutrons. So the number to be calculated. Okay, so proton. So proton number means this 6, right? This is called number of protons. So if number of protons are 6, then always the new electron number also will be same, so that we can say the atoms are actually neutral, right? So that is why atoms behave as a neutral in nature. So that here protons is actually 6. So if proton is 6, then electron will be the same number only, right? Then how do you find neutrons? This is that thing. Now you have to find neutron number. Neutron number to be found by the easy method called atomic mass minus atomic number. So here atomic mass can be denoted by A. Atomic number, what we call proton number, also can be denoted by Z. So here this is called atomic mass A. Understand? And the 6 is actually called Z, atomic number or proton number also. So 12 minus 6, it's gonna be a 6. So there are 6 protons, 6 electrons, and 6 neutrons present inside the carbon atoms. So now look at the definition. If proton number is equal to the neutron number, or if the neutron number is lesser than the proton number, then that kind of atoms, isotopes, are stable, or that nucleus will be stable. So here we have 6 proton and 6 neutron. That means the proton number and neutrons number are equal. Proton number, neutrons number actually equal. Look at it here. So that this element will be stable. But in case of uranium-235, uranium atomic number, can you tell me? Uranium atomic number. Your atomic number of uranium is 92 and its mass number is 235. So find first the neutrons. Neutron, how to be found? 235 minus 92. It's very simple. Just subtract mass number minus atomic number. You're going to get it here. So I will be finding here about 143, right? So this is the number of neutrons present in a uranium element. So now proton number, it's clearly visualizing, it's there already, right? This is 92 is the proton number. Now look at the proton number is 92, but neutron number is 143. So here it has extra number of neutron present. If it is 92 or 92 proton number and neutron number, then it would be stable. But here number of neutrons are excess. 143 neutrons are there, but proton number is only 92. So that is why this nucleus is called unstable nucleus. In case of uranium, the uranium nucleus is unstable. Okay, so this Cu12 I have written this example for stable, and uranium 235 it is example of unstable element. Okay, remember, unstable nucleus, if you find, then that type of element is actually said to be unstable element, or on the other word we called it radioactive element. Okay, radioactive isotopes also you can say. Radioactive isotope. It is clear now? I hope you understand about the stable nucleus and unstable nucleus. So always remember it. The radioactive element only can be used for the nuclear reactions. Okay, radioactive element only can be used for nuclear reactions. Now, this is the nuclear fission reactions. So, is it clear now why I have taken here uranium? So, uranium is a radioactive nucleus. This nucleus is unstable nucleus. It is a big nucleus. Okay, so when the one neutron is being heated, here it divided into two types, two smaller nucleus, and form huge amount of energy and produce three different neutrons also. And even let's suppose this one neutron is being heated to krypton, then again this krypton will be divided into two different smaller nuclei and producing energy as well. Let's suppose this neutrons is heated to barium, so it will also divide into two different smaller nuclei and will produce energy and neutrons as well. So this is going to be a chain type of reactions. This is going to be chain type of reaction. So you remember nuclear fission reaction is a chain reaction. Is it clear now? So you might be having question, teacher, what is the greater application for the nuclear reaction? What is the useful of these reactions? You will be amazed if I say now it has a great inventions by means of the nuclear fission reactions. Have you heard about atom bomb? How atom bomb is being made? It is because of nuclear fission process. Nuclear fission reaction. By the help of this process, atom bomb was made. Then who discovered for first time atom bomb? The American scientist. He is none other than the great scientist. It's called Robert Oppenheimer. He is the scientist for first time he discovered atom bomb. Okay, and you will be amazed to know, you will be surprised to know that the first atom bomb was dropped in Japan from the US, from United States of America during the World War. Which World War? Second World War times, in the year of, I guess, 1945. The first atom bomb was dropped in Hiroshima, 6th August 45. So that name of the atom bomb, the code is known as Little Boy. Little Boy is the code of the first atom bomb was dropped in Hiroshima, August 6 in 1945. And this atom bomb was made by means of uranium element. So uranium 235. Okay, uranium also has isotopes, three different isotopes. So specifically they used uranium 235. This radioactive element was used to make the first atom bomb. This is the diagram for this little boy. And on the right side, you could find it the yellow color. This is also the atom bomb. This was the second atom bomb. Second atom bomb. Okay. So what could be the code of this atom bomb? Do you know? You text me. Use the chat bar and then text me that what is the code of the second atom bomb. The code of the second atom bomb was Fat Man. Fat Man. First was this little boy. First, it was a boy, and then it became fat man, the second atom bomb. Okay. Then, teacher, what element was used for making the second atom bomb? First was the uranium. Uranium was used for making little boy, and plutonium. Plutonium atomic number 94. Plutonium 239 was used to make second atom bomb. It was dropped after 3 days of the second world in August 9, 1945, in the place of Nagasaki. In the place of Nagasaki. So here you remember it. Sometimes you might be having questions in examinations about the type of atoms and what are the element were used for making two different atomic bomb. So first atom bombs and second atoms. Here the easy way to make you to understand, here I'm going to write it for you. Okay, diagram, did you see this diagram is pretty clear for you? So here I'm going to share you the screen so that I can explain you in a proper manner here to remember the date, remember the element and the code. Okay, the first atom bomb name was called Little Boy. Little, just these spellings are actually going to be mixed. Little Boy. Which element was used? Uranium 235. Okay, when it was done? Where it was done? It was in Japan. Spellings, you just carefully have to look at it. Japan, in the city of, first was in Hiroshima. When? 6th August. I'm not writing complete spelling. 1945. It is the year, okay, during the Second World War. And the Fat Man. Fat Man. The Fat Man, which element was used? Plutonium. Plutonium atomic number 94. It's 39. Clear. The same country, Japan, and it was dropped from the America, US. Okay. So in the same Japan, but in different city. Which city? Nagasaki. After just 3 days of the first atom bomb. So it was 9th August 1945. Okay, so in history you might have studied about those places. So this is the place of Hiroshima is the place of Japan. It's a city. During the World War times, US dropped first atom bomb. What was made? Now it was made by uranium 235. And how it is made? By means of nuclear fission processing. Okay, and you know, it was really the memorables and the famous incident happened in the worldwide. Okay, so easy to remember. Little Boy, the first atom bomb, first one. The second one is called Fat Man. How to remember the elements? So it is uranium 235, and Fat Man was plutonium 239. Okay, Hiroshima, the place, the city name, the first atom bomb, and the second one is Nagasaki. So here the place easily you can remember. Hiroshima, the H letter comes first in the English alphabet, and then after the letter N comes. So remember at least the alphabet, the first alphabet. H comes first or N comes first? Obviously H. So that is why Little Boy, the first atom bomb. Secondly, the Nagasaki, N letter comes secondly in the English alphabet. So the Fat Man. Okay, the date was 6th August. The first And the second atom bomb was dropped in 9th August. Element was uranium and plutonium in the second. Is it clear now? Now you might have questions. Teacher, if a total atom bomb is being dropped somewhere, what would happen? How the people will be being affected because of the atom bomb? Is it really powerful or is it dangerous? So as far as I understand, I explore about it, it is a dangerous. It's not very powerful like a hydrogen bomb, right? So let's say it is an atom bomb. This is atom. Now this place is being dropped by this bomb. So what happens, you know, it radiates different type of wave. Okay, so like gamma ray will be released here. What ray? Gamma ray is very dangerous. And then here X-ray also will be radiated from here, X-ray. And then just back of them, there will be shock wave. Shock wave. Okay, these are the highly radiated rays. Because of this radiated rays, all the places where it is dropped, the people, the living things and non-living things will be damaged, completely demolished. So imagine, remember it, where the place the bomb was dropped, maximum it can spread about 5 to 10 kilometers. Okay, the size of the bomb, obviously, let's say this is my room, right? It can be 20 by 30 meter distance, the size of the bomb. The particular place you can find the fire can be seen, and the smoke and all. But you might be thinking, if atom bomb was dropped, then completely like 10-kilometer distance, the people will be burnt alive. Can it be like this? No. Where the bomb was dropped, obviously, of course, the fire will be, you know, fire can be seen, fire can be produced over there in the particular place where it is dropped, but not entire places. Okay, because of the, it can spread, yes, it can spread to maximum 10 kilometer as per the range of this atom bomb, how the efficient they have made it, what was the range of this atom bomb. So maximum it can lead 5 to 10 kilometers. It can spread to 5 to 10 kilometer distance. So around this kilometers, around this distance, the people will be start to affect in the next day of the atom bomb dropped. It will be not instantly will be affected instantly, only the area where it is dropped, very close areas. But because of this highly radiated waves, because of this, all the things, the food, the house, the kitchen, the plants, and whatever the materials, that will be completely polluted by this radiated rays. Understand? So whatever the things you touch it, whatever the things you eat, completely it is a the things is completely radiated, right? So that because of this gamma rays, X-ray and shock wave, so that things will kill you inside your body. Slowly the kidney is going to be damaged, and then the heart will gonna be stopped. And you know, in fact, as soon as the atom bomb is dropped, this will make the area, especially that area, the temperature can be increased uh, very rapidly to 300 degrees centigrade. So imagine in 100 degrees Celsius, if I take this water will boil and will become, you know, vapor form of water, what we call it, gas form of water, right? In 100 degrees Celsius, you imagine if 300 degrees Celsius, what would happen? Okay, if the hot water is just poured in your screens in 100 degrees Celsius, then our skin used to burn it like anything. So just you think about it. If at all the surrounding temperature is 300 degrees Celsius, what could be the consequences of yours? We will be completely burned like anything. Okay, and this gamma ray, they can penetrate through your body. Gamma rays, X-ray, they can penetrate your body. Shockwave can demolish the building. Shockwave can demolish the buildings, can destroy the things, houses, trees, and everything. So that area will be completely damaged. So in fact, I would say that this atom bomb is not a bomb. It is a highly radiated pollution, actually. Highly radiated pollution. So it is dangerous, not powerful, like hydrogen. Okay, so if at all the place you have affected with this atom bomb, then probably you can get, if you have potassium iodide tablet, so that will protect you from this radiated waves, rays, from these pollutions. Okay, what one? What tablet to be taken? Potassium iodide. Or if boric acid also will work efficiently against this atom bomb, the pollutions from this radiative substances. Understand? Mostly, if you have potassium iodide tablets, you can consume, then you will be protected from this highly radiated rays or waves. Okay, so these nuclear fusion reactions, nuclear fissions reaction, if it is control, if you can control, then that is actually, we called it nuclear power plant. Nuclear power plant. If this reaction happened in control level, okay, if it is under control, then you can make the electricity by using this element. Uranium is nowadays used to generate electricity, uranium element. Okay, so uranium element is used to generate electricity. So nuclear power plant. And where? And so that is why we called it nuclear power plant. So if this reaction under control, then that's going to be a nuclear power plant. So nuclear atomic plant, we can say. Okay, we can say atomic plant. If this nuclear fission reaction takes place under control, then it is called atomic power plant, where we generate electricity. Where we generate electricity. Understand? So generally uranium, thorium also, now scientists are working for using thorium element. Okay, so that they can be producing, generating electricity by using thorium element. But as of now, uranium is used to generate electricity. But you might be having questions, teacher, if it is under control, that is known as atomic power plant. If it is not under control, if it is not controlled by us, then that is only going to be the atom bomb. It will be known as atomic bomb. Okay, if it is the nuclear fission reaction not under control, then it will turns out into atom bomb. Not under control. Okay, then it will be known as atomic bomb or atom bomb. Okay, so is it clear for everybody? I hope the basics of this fission reactions is clear for you. So now let's understand about the second type of nuclear reaction. Is called nuclear fusion reactions. Nuclear fusion reactions. So it is also very simple. Nuclear fusion reaction, also fusion reaction is simple. So don't get confused about it. That was nuclear fission. Spelling was FISSION. Okay, but this is also nuclear reaction, but nuclear fusion it is. Okay. So two light nuclei combine to form a more massive nucleus, and it releases the energies, basically is known as nuclear fusion reactions. Okay, so for example, let's say here we have one, I have two mobiles. So this is one smaller nuclei, for example. This is another smaller nucleus. When I combine together, so it became big nucleus. It became big nucleus. When I combine, by the time from here, the energy also will be released. Energy also will release. So this type of process is known as nuclear fusion. Okay, small one combine to form big one, and energy is released. So for first time, the nuclear fusion reaction, the great application is formation of hydrogen bomb. So hydrogen bomb, here you can see this picture diagram. It is actually the diagram of hydrogen bomb. So hydrogen is bomb made by means of this process called nuclear fusion reactions. So for first time, hydrogen bomb was made by Edward Teller. So father of hydrogen bomb, you can say Edward Teller. Understand? So it is very simple reaction. So this is also chain reactions, and this nuclear fusion reactions, it cannot be controlled as of now. The scientists already described it is not under control. Okay. So if, or maybe later, if scientists they've discovered about, yes, it can be controllable, then by the time we will discuss more it. But as of now, the hydrogen bombs, it is also a chain reactions. It needs a lot of energy, temperature to be prepared, and moreover, it is not under control. So here in this diagram, you can see how the small nucleus, for example, hydrogen, the deuterium react with tritium, another small nuclei, then combine together to form a new compound called helium. It's a big nucleus, and here energy also will be being produced. So this is tritium react with deuterium, fusion takes place. Now see, energy is released and new compound helium is produced. Of course, neutrons also gonna produce from it. So this is called nuclear fusion reactions. Okay, so this is all about the difference between nuclear fission reactions and fusion reactions. So in the quickly, I will be telling you about the differentiations here. Okay, fissions, it split the larger atom into two or more smaller one, but fusions join two or more lighter atoms into larger one. So they are opposite to each other. So I hope this video is helpful for you, and you might have understand, you might have you might have understood about the difference between nuclear reactions, chemical reactions, how atom bomb is made by which process, and how hydrogen bomb is prepared. So all in details I shared with you. So thank you so much for watching this video.